Okay. Okay, so the last thing that's on this worksheet, and if you just want to write this down and get it in your notes, at least we can do that, okay, is we can talk about the composition of compounds by mass. We just talked about figuring out how many moles of a certain element are in a compound. Now we can do ratios of mass, which is, or depending on your situation, might be more useful, okay? And so when I'm doing this ratio, I'm going to set it up as a percentage, okay? And so in order, I'm sure we know percentages, I'm just going to take the total mass of the compound, and then on top I would put the mass of an individual element and just divide them, right? That's how percentages work, okay? The mass of an individual element divided by the total mass times 100%. That's the percentage of a compound by mass, okay? And what we'll keep in mind is that the total amount doesn't really matter. The percentages will stay the same. So if I have a compound that is 50% carbon and 50% nitrogen, whether I have one atom or one molecule or 25 kilograms of it, the percentages is still 50-50. Okay, so the total amount doesn't matter. Okay, and so we're just going to pick a total amount that's most convenient. And a lot of you have already figured out we're going to just assume 1 mole. That's what we assume the total is, because the percentages come out the same. Okay, so simple example, if I have water, I want to know what percentage of water, of its mass, is from the hydrogen versus the oxygen. Okay, and it's not a 2-to-1 ratio. Yes, I have 2 hydrogen atoms and 1 oxygen atom, but their masses are not equal. Hydrogen is 1 gram or 1 AMU, and oxygen is 16. So even though the atoms is kind of a 2-to-1 or 2 out of 3 and then 1 out of 3, the masses don't shake out that way, okay? So what we're going to assume is that we have 1 mole of water. Okay, if I have 1 mole of water, what's my total mass? How would I figure that out? 18.0153.
Yeah.
How do you know that? Where'd you get that from?
You take the atomic mass or the molar mass of each element and add it up.
You just add it all up. You just find the molar mass based on the periodic table, okay? So 18.0153, I just know that because I did this earlier today, okay? So all of my water together is 18 grams roughly, and I want to know what percentage of this is the hydrogen atoms and what percentage of this is the oxygen atoms. Well, if I have 1 mole of water, we can use the molar ratios we just talked about. I know that I have 2 moles of hydrogen and 1 mole of oxygen. Right, those are the molar ratios. And if I have 2 moles of hydrogen, I can figure out the mass of that. Based on the periodic table, I just take 2 times its mass. If I have 1 mole of oxygen, I just take 1 times its mass, which is its mass. Okay, so out of the 18 grams of water, about 2 of those grams is hydrogen atoms, and about 16 grams of it is oxygen atoms. So then if I wanted to figure out the percentage, I just divide them. Right, 2 grams divided by 18 times 100%, about 11% is hydrogen. And if I do the same for oxygen, I get that about 89% of the mass is oxygen. Okay, so even though there's only 1 oxygen atom, it's so big and bulky compared to hydrogen, it takes up most of the mass. Oops.
How would you type in the times 100% in your calculator?
I would just do times 100
Okay.
and then just write in the percent.
Okay.
Yeah,
I was like, that's a dumb question, but
you're fine.
making sense.
Don't worry about it. Okay. I mean, at least just giving us the opportunity to write it down, and then maybe we can come back around to it and actually get it in our brains from there. Yeah. This one? What I did is I knew I had 2 moles of it, so I took 2 times the number on the periodic table. If I take the mass on the periodic table times 2, I get that. Yeah. Other questions? Okay, can I show you the next slide? Okay. So just one other example. Let's say I want to do the same thing for barium nitrate. Okay. I would need to know the chemical formula of barium nitrate, which is BaNO3,2. I'll just give that to you. And for convenience, we're just going to assume that the total amount we have is 1 mole. The total amount doesn't really change the percentages, so let's just make it easy on ourselves and just assume 1 mole.
So when we calculate percentage, will we do it in like a full number, or will we do it?
You would technically do it based on sig figs from your molar masses.
Okay, I just looked at
But I know that the molar masses are going to be different on each periodic table you use, so I'm not going to grade on sig figs with these.
Okay.
Do like 2 or 3 decimal places. Don't round it to the ones place, then you get too much rounding. Okay, so we need to use molar ratios. If I have 1 mole of barium nitrate, how many moles of barium do I have? 1 mole. If I have 1 mole of barium nitrate, how many moles of nitrogen do I have? 2, yeah, 1 times 2. What about oxygen? 6, yeah. Okay, 1 mole of barium, 2 moles of nitrogen, 6 moles of oxygen. So first thing I need to do is calculate the total mass. So the total mass of barium nitrate is, oops, did I not put it on the bottom? That was dumb. It's on the bottom, 261.3368 grams. And then I'm just going to take the mass of each of those elements with how many moles they are. And then I set up my ratios. I'm going to divide all of them and get my percentages. Okay, so 137-ish divided by that, you're about 52%. If I take my mass of nitrogen divided by the total, I get about 10%. If I take my mass of oxygen divided by the total, I get about 37%. Okay, so that's the general idea of how these work.
Could you,
Question?
can you go back to the other side of the second page where it's not
Yeah.
I'm good.
Okay, so I just want to show a few examples of that.
That makes sense.
Cool.
Yeah, this makes more sense to me than this. So.
The other thing before? Okay. Yeah, well, the fun fact is that this uses what the other slides were. So maybe doing this, going back, it'll be easier. Going backwards, I don't know. Okay. Cool. No new worksheets, just what I gave you. I want to do a lab tomorrow, so we'll have some time.
How's our own picture?